Dear students, welcome to my channel. In our operating system tutorial, today we will discuss Introduction to Thread. As you know, thread is a lightweight process. A process consists of many threads. So myself, Niladri Shekhar Pal, I am working as an assistant professor at Computer Science and Engineering Department at Greater Kolkata College of Engineering. So what is thread? A thread basically a lightweight process. It is the basic unit of CPU execution. Okay? And it consists of many things like thread ID, program counter, set of registers to hold the information of current working variables, and stack, which includes the history of execution. Basically, thread ID for identifying the thread. Okay. Actually, a process consists of many number of threads. Okay. So to identify the thread, we use thread ID, and the program counter is used for to identify which thread will run next. Okay, and the set of registers is basically the information, okay, of the variable which are working with the associated with the thread. Next, a thread shares same information, okay, to its associated thread, and the information consists of open files, the data segments, and code segments. Okay, so all the threads share same information, okay, which are associated like open files, data segments, code segments, etc. If a thread changes a code segment memory item, then the other thread can see the changes in the thread. Suppose there are 4 threads are working in a process. Suppose there is a change in a single thread. Okay, so you can get or you can see the other changes in other 3 threads also. In other words, a thread is defined as a flow of execution via a process code. Okay, so it is defined as a flow of execution via the process code. Thread improves the performance of applications with the help of parallelism because threads are execution in parallel manner. Okay, so it improves the process speed or execution speed as we know that the process consists of many threads and all the threads are working as parallel manner. Okay, so though it is working as a parallel manner, so the execution of the process becomes faster. Next, every thread is related to a single process, and without process, thread cannot exist. As I told before that all the threads are associated with process. Okay, a process consists of many lightweight threads. Every thread shows a distinct flow of control. Okay, so as I told that a process consists of multiple threads and each thread has its own working culture. Okay, and threads are used in implementing web servers and network servers also. Parallel execution of the application is applicable in thread, which can be shared among the memory multiprocessors. Okay, and therefore next, working of a single thread and a multi-thread process. Okay, so in our picture, okay, we can see that there are 2 pictures are there. One is single process thread and another is single process multiple thread. Okay, there are 3 threads in my right hand picture. Okay, in this picture you can see that there are 3 threads. Okay, and for the 3 threads there are different codes are there, but all the threads are working on the same data and same files, and for each thread there are different register, counter, and stack. Okay, so there are 3 threads in this process and all the threads have different codes, and for each thread there are different registers, counter, and stack. Okay, so as you can see, the first thread there are 3 different register, counter, and stack, and for second thread there are also different register, counter, stack, and for third thread also there are different register, counter, and stack. But for all the 3 threads there are the same data and files. Okay? And this is the single thread for single process, single thread. Okay, as you can, a single thread has a single code, single data, single file, and single register, counter, and So what is the difference between process and thread? Basically, a process can be defined as a program in execution. Okay, so basically a program is within the secondary memory. Okay, so but a program is on an executable state. Okay, then it is called a process. But a thread can be defined as the flow of execution via the process code. Okay. In the process, switching requires interaction with the operating system. But in case of thread, in thread switching, there is no requirement to interact with the operating system. Next, in point 3, it is a heavyweight, okay? And in case of thread, it is a lightweight process. In point 4, the process consumes more resources. So process needs more resources, okay? But thread consumes fewer resources. Context switching requires more time in process. Okay, so context switching is possible in case of process and it requires more spaces. But in thread, context switching requires less time. Okay, the process needs more time for termination. Okay, the process actually what happens? A process consists of many lightweight threads. Okay, so when a process need more time than thread, as you know that a process consists of many threads, so at first all the threads have to complete their execution. Okay, so that we can say that the process has completed. So as I told, the thread takes less time for termination as the thread is smaller than process, and the process takes more time for creation, but the thread takes less time for creation. Okay, so as process is much more bigger than thread, okay, so it takes more time for creation. So I am again repeating that the process basically can be defined as a program in execution, okay, but a thread can be defined as the flow of execution via the process code. Next point, in the process, switching requires interaction with operating system. In thread switching, there is no requirement to interact with the operating system. Process is a heavyweight, but thread is a lightweight. The process consumes more resources as it is bigger, but thread consumes fewer resources as it is smaller than process. Context switching requires more time in process. Okay? For context switching, it requires more time in this process. But context switching requires less time in case of thread. But in process, the needs more time for termination. But the thread takes less time for termination. The process takes more time for creation, but the thread takes less time for creation. Okay. So next come to the advantages of threads. Number one is better CPU utilization. Okay. So if multiple threads are existing in one process, they can be scheduled on different processes, which makes the process execution quicker. So as I told that a process consists of multiple threads. Okay, so they can work simultaneously or parallelly. Okay, so the CPU utilization will be much more faster. Okay, so all the process executed faster. Next, increase throughput of the system. If a process is broken into different threads and each thread task is considered as one job, and the number of jobs done is increased per unit of time, thus the throughput of the system also increases. Okay, and the next point is communication. It is very important. In the thread, communication is quite simple. Why? Because each thread shares a common address space. Okay, but in the process we use some specific communications method for communication between the processes. Next point is resource sharing. As resources can be shared easily between all threads within a process, such as data, files, and codes. Okay. Next point is responsiveness. When the process is broken into different threads, and if any file we finished its execution, the output of thread is returned instantly. Okay. So I am again saying what are the main things, what are the advantages of thread. First one is better CPU utilization. That means if multiple threads are existing in one process. Okay, they can be scheduled on different processes, which make the process execution much faster. Okay, so in case of thread, we execute the process much faster. Next point is increased throughput of the system. If a process is broken into different threads and each thread task is considered as one job and the number of jobs done is increased per unit of time, okay, so thus the throughput of the system also increases. Next point is communication. In the thread, communication is quite simple. Why? Because each thread shares a common address space. But the process we use some specific communication methods for communication between the processes. Next one is resource sharing. Resource can be shared easily between all threads within a process, such as data, files, and codes. Okay. Next one is responsiveness. When the process is broken into different threads, and if any file finished its execution, the output of the thread is returned instant. Okay, so students, this is all about threads. Okay, so in our next chapter, we will discuss what are the different life cycle of thread. I am requesting you to subscribe my channel by click the bell icon on your right hand side of the screen. Okay, by subscribing my channel, you will get all the notification of my video tutorial, or you can visit www.facebook.com/digital classroom Niladri Pal, or you can like my page to get all the notification of my video tutorial. If you have any problem, you can mail me at niladripl86@gmail.com, or can call me at my mobile number. Okay students, thank you. See you in my next video tutorial.